In this lesson, you will learn about one-sided limits. Consider um, consider the piecewise function f of x represented on this graph. If x approaches 5 from the left, f of x approaches negative 3. If x approaches 5 from the right, f of x approaches 4. Therefore, the limit of f of x as x approaches 5 does not exist. Now, let's consider value of x that are only to the left of 5. So the value are smaller than 5. For these x values, f of x is getting closer to negative 3 as we get closer and closer to 5. So we can say that the limit of f of x as x approaches 5 from the left is negative 3. We notate this by putting a small negative sign next to the 5. Now let's look at the value of x that are only to the right of 5. These x values are greater than 5. For these x values, as we get closer and closer to 5, the value of the function is getting closer and closer to 4. So we say that the limit of f of x as x approaches 5 from the right is 4. We notate this by putting a small positive sign next to the 5. So these are one-sided limits. And look at the next function. For part A, we are finding the limit as x approaches 1 from the left of f of x. Looking at the graph, if we follow the function, we can see that we are getting closer and closer to 1. For part B, we are finding the limit as x approaches 1 from the right side of f of x. Looking at the graph, if we follow the function from the right side, we can see that it is approaching negative 1. Looking at the graph from the previous problem, we find that the limit as x approaches 1 from the left is equal to 1. And the limit as x approaches 1 from the right is equal to negative 1. Now, if we wanted to find the limit of f of x as x approaches 1, once again, we would say that it does not exist. Not exist. We said that a limit exists as x approaches a number c if, and only if, the limit as x approaches c from the left is equal to the limit as x approaches c from the right, in general for any function of f of x. Like this. In general for any function of x, function f of x, the limit as x approaches a number c exists and is a number L if and only if the limit of f of x as x approaches c from the left is equal to L, and the limit as x approaches c from the right is also equal to L. We can say that the limit of f of x as x approaches 3 exists because the limit from the limit from the right and left is equal to 3. Therefore, the limit exists. Now, the limit of f of x as x approaches negative 3 does not exist because the limit from the left is approaching 1, and the limit from the right is 0, and they are not equal. And in this problem, use one-side limit to evaluate the limit of x minus 1 over x minus 2 as x approaches 2. We need to use one-side limits to find the limit of x minus 1 over x minus 2 as x approaches 2. First, let's find what value of function is approaching when we approach 2 from the right. Now, we're just gonna estimate, and we're just gonna use the table or pick a value for x and plug it in and see what we get. So since we are on the right of 2, I'm gonna pick 2.1. So when I plug in 2.1 for x, I get 2.1 minus 1 over 2.1 minus 2, which we get 1.1 over 0.1, which is equal to 11. Now, this is not necessarily the limit, but when x is 2.1, our value of our function is 11. Now, let's see what's going on the left side. Now, let's pick a value from the left. So I'll pick x is equal to 1.9. Now, when I plug in 1.9 in for x, we get 0.9 in the numerator, negative 0.1 in the denominator, which gives me negative 9. Now, once again, that's not the limit. But we can see that from the right and the left side, the value of our function, as we are somewhere close to 2, are approaching 2 drastically different things. So I can conclude just from this small example that the limit is not going to exist. So using the right side and left side limits will help us conclude where the limit does not exist.